application problems. And these are the kinds of application questions that you saw last year. And now, last year we sat there and did trial and error to solve for the exponents. Now you know how to use logarithms to help you solve for the unknown exponent. So let's take a look at the question. So, Asan invested $500 at 8.5% per annum, compounded annually. This investment is now worth $5,000. And how long has the money been invested? So there's a little hint here reminding you of the formula we used last year to help us solve any financial problems. And so what you're told is the principal amount that was invested, so that's P. You're also told the interest rate. So this is the interest rate that we're looking at, which is 8.5% as a decimal. So what that tells me is that the interest rate as a decimal would be 0.085. And then we're told what the accumulated amount of the investment is. So we're also told the value of A. Now if I plug in all this information into the equation, you'll notice that we have the accumulated amount, we have the principal amount, the amount that was invested initially, and we also have the interest rate as a decimal for the account that was invested in. And so the only variable left to solve for is T. And if we look at the question again, it says how long has the money been invested, which means we're solving for a time value. Now let's plug in all the values and see what we can do from there. So we have 5,000 equals 500 multiplied by 1 plus 0.085, which is 1.085. And that's raised to the exponent T. Okay, now this question is very similar to one of the questions that we did earlier in example 4. And so it's very easy to solve for this for the exponent of T in this case. I'm going to start by dividing both sides by 500. Okay. I don't want to take the logarithm of both sides yet. Okay. I know that's what we did in the previous question. We did look at the logarithm of both sides. But remember that anytime you have a coefficient that you can eliminate that first. It'll make your work a lot easier. Okay? And so what I end up getting is 10 is equal to 1.085 to the exponent T. Now at this point, because the only thing I have on the right hand side is a base with an exponent applied to it, then that means I can take the logarithm of both sides. Okay, so I'm going to have log of 10 equals log of 1.085 to the exponent T. Now again, using the power law of logarithms, I know that this is the same as writing log of 10 equals T times the log of 1.085. And now to solve for T, I can divide both sides by the logarithm on the right hand side. So get rid of log of 1.085 by dividing it on both sides. And so I get T is approximately equal to, and the rest of this I can do on my calculator. Log of 10 I know is equal to 1. So log of 10 should be equal to 1. I'll do that again. So log of 10 is equal to 1. Divided by the log of 1.085, which is a small decimal number. And that's equal to, in total, 28.2 approximately. So what that means is it took about 28.2 years for the money to increase to about $5,000. So therefore, he invested for about 28.2 years.